Welcome back. In this video, I'll be showing the demo on this free space table. Here you can see that I've created three disk groups DG1, DG2 and DG3. One of external and the other disk group of type normal and the one of type high redundancy disk groups. DG3 has an allocation unit size of 4 MB, whereas the other two has an allocation unit size of 1 MB. The size of my disk is 3 GB. Let me query for the disk's information. So as I said in the previous video, block 1 of allocation unit 0 is reserved for free space table. So before I show that information, let me clarify one thing. As I said, the size of my disk is 3 GB, so which is nothing but 1024 into 3, which is 3072 MB, and size of one allocation unit is 1 MB. So in my file I can have 3072 allocation units. As we know that one allocation table block can contain information for the 448 allocation units. So if I divide this by 448, then the result is 6.8, which means that I need at least 7 allocation table blocks to address all the allocation units that are there on my disk. Now let's verify the same. I'm using the kefet read command to read the disk 11, which is part of normal redundancy disk group. And it is allocation unit 0 and block number 1. Here we can see that total 0 to 7, so which is 7 allocation table blocks are addressed here. So here we can see some value for the free allocation table blocks, for the free allocation units in this allocation table blocks. As I said, allocation table block is indexed for the KFD FST data structure. Now first let me try to create the data file to use the maximum space that is available on the disk. I'm creating a tablespace TB1 with data file into disk group 2. So size of my disk is 3 GB, so I'm trying to use the maximum space for this table space. And remember this, the highlighted entry here, we can see the values 119 for all the 7 allocation table blocks. So offering this space, once this data file got created successfully, then there should not be much allocation units that can be addressed in this entries. Let's cross check the same. So this would take some time for creating this table space. Now the table space got created. So I'm using this free space table information. Now here, if you can see here, the first 6 allocation table blocks has 0 free allocation units. So it means that these blocks will never be scanned for any allocation unit that is required for the new file. So this way, free space table provides a summary of which allocation table blocks having the free allocation units. So now going back to the disk group DG3 with the allocation unit size of 4 MB. So let me come back for that. So size of my disk is 1024 into 3, that is 3 GB, which is nothing but 3072 MB, and size of one allocation unit is 4 MB. So divide by 4, I'll be having 768 allocation units in my disk. So if one allocation table block can address 448 allocation units, then I'll require 2 allocation table blocks to address all the allocation units on my disk. Now let's verify the same here. So 13, 14, 15 are the disks of my high redundancy disk group DG3. So I'm using disk 13 to verify the same. Here we can see that only 2 blocks have been used. It has the entries for only 2 allocation table blocks. So as per our previous calculation, we need maximum of 2 allocation table blocks to address all the allocation units on the disk. So now this free space entry shows the information about the allocation units that are free in this allocation table blocks. The allocation table block number is indexed as shown 0 and 1 here. Now let's try to create a data file and consume all of this space on the disk. Let me go back to database. I'm creating a tablespace 2 data file in DG3. Size, I'm utilizing the complete most of the space on this disk. Again, this command would take some time. Just remember the highlighted section here. There's 2 allocation table blocks. We're showing some number for the free allocation units in those blocks. Once this table space got created successfully, then there should not be much free numbers that can be visible in this data structures. has to mark all the allocation units in the allocation table with the extent number and the file number. So this will take some time for updating the data information. Yeah, now this table space got created. Now let's verify this from the free space table information. So I'm querying the disk 13. So now here we can see that the first allocation table block has no more free allocation units. So that block is completely utilized, and going forward, these blocks, these allocation units will never be scanned for free allocation units. And in the next block, allocation table block, we have only free allocation units that can be used for the data files. So this way we can edit or we can view the information from the free space table. So with this we conclude the physical metadata structures of ASM. Thanks for watching this video.